Wow, good morning, everyone. There's a lot of folks here. You guys going to be ready for this? There's a lot of people here.
Yes.
Well, welcome. Good morning. Today we are exploring how technology is not just supporting, but redefining what's possible in mission-critical operations. We're really pleased today to have Vice Admiral Goucher, Commander of Submarine Forces, and Dr. Neil Thurgood, Senior Vice President from Anduril, here to talk about some really interesting topics that I think you'll all find very inspiring and very informative. So to get started, let's start with a quick snapshot, gentlemen. What does breaking barriers look like in your world right now? And what role is technology playing in that for both of you?
Well, I'll start off, and I'll be a little critical of the military, but I'll try to be very honest. We, I think, have a tendency to self-constrain, and so we tend to live within the rule set. And in fairness, most folks in the military, and particularly in the submarine force, where we're brought up with our nuclear principles, we follow the rules. With our rule sets, many of them were built in the 1960s, 1970s, 1980s, when we were hand calculating and keeping track of things in ledgers. And so it required a lot of regulation, a lot of process to make sure that we didn't make errors and that we were good stewards of the money the government provides us or the missions that we're tasked with doing. I think with technology now, we're really having to rethink not just what technology can do for us, but the rule sets that we're applying to that, so that instead of taking 21st century technology and mapping it to a 1980s rule set, we're going to look and say, hey, how do I throw that whole rule set out because I have technology, right? I don't need to calculate and audit anymore. I've just got to get the algorithm right and test it the first time, and then know that it's locked down and secure, and then I go off and run, and I can eliminate a whole bunch of overhead in that. And so I think the barriers that we mostly face is in thinking about things in a different way and leveraging what technology can bring to bear, not just doing what we've always done a little bit faster.
Great.
Yeah, thanks. Well, first of all, just before we answer the question, thanks for letting us be here today. Having just retired after 38 years, let me say thanks to Rob for serving our nation, and for all the veterans that are out here, thanks for all you've done for our nation. I think it's interesting as we think about the barriers that we break in technology, and I think there's kind of three areas to focus on. So first, Rob mentioned, is the rate of technology adaptation has to be accelerated. So we have to break the barrier of how we think about adaptation of technology. That means looking at the processes we use inside the Department of Defense, the processes we use in industry, and how do we match the industry speed with a DoD process, right? Other than changing the law, then we have to find a way to bridge that. And I think spending time and effort thinking about how to break the barrier of process and within the legal constraints given to us by Congress, we have to show that the department how to do that. The second is that we have to think about this idea that the majority of the senior leaders in the department are digital immigrants versus the current generation, which are digital natives, right? So we have to help the department think about technology in a way that they don't. I remember sending my first email on a big computer that was as big as a suitcase. I thought that's just so cool. And so we have to think about, and Rob mentioned this, how do we use the warfighting constructs that protect our nation, and how do we use technology to help us do that? In the earlier panel, there was an interesting piece that was using technology with a human at the critical time. Was a quote from the earlier panel, and I think that's really important. So breaking barriers is not so much a mechanical process as it is a thought process. And how do we think about the adaptation of technology, the speed at which industry can do it, matching that with the process the government can do it differently, and then thinking about how we use that against the doctrines in the Department of Defense.
Wonderful. Well, thank you. Vice Admiral Goucher, I'm going to go to you for this next question. So you lead operations in one of the most data-intensive, high-stakes environments in the military. As our services race towards autonomy and AI, there's a fine line to balance with trying to do too much, too fast, and maintaining strategic advantage. How do you see data as the foundation for enabling autonomy at scale while maintaining the precision, safety, and operational readiness that you need?
Yeah, so that's a big question.
I'll try to
take a few things. So let me start with the importance of data. So I think this has been something, and I can very confidently say the Navy has embraced the need for data. The problem that we have is that as we kind of first realized that computers were a good idea, so we all bought computers. Then we decided, hey, we're going to network computers, and then we had to build boxes so they could talk to each other. And now we're realizing that I have all this data. I got to figure out how I display it. We've recognized the value, and so we're struggling with. I don't say struggling may not be the right word, but we're working towards getting it into a way to use daily visual management to help us oversee a huge organization, right? So before we even get into the autonomy piece, we're using that for our daily readiness. And as I look across 70 submarines that I have to keep track of, I have to make sure they all have the right people. I have to make sure they all have the right parts. I have to make sure they're all trained for the missions I ask them to do. And so the only way that one person or one staff can do that is having a good data environment to understand, hey, where are the areas I need to pay attention to, where I might have a force-wide problem that is all of a sudden going to manifest itself 70 places at once. I mean, I'll always have onesie-twosie things, but we're pretty good at swarming one thing, but I can't let all of that get in front of me. Now, to go to your second half of your question of autonomy at scale, well, I mean, the way I see data is, that is really the underpinning of all autonomy, right? And if we look now, getting back to the last question, there's a certain amount of fear with autonomy, right? So we're all worried about Skynet, and how do I bring that to bear? Having confidence is really what I have to get to. So if I get to a policy or a decision maker and say, hey, I want to take this autonomous system, so I'm going to have a robot go do an operation that normally a human does, how do I convince somebody that that's going to be okay? Well, data is really the currency that I have to show them, hey, I've run this vehicle 100 times, I've got 1,000 hours on it, I know exactly what the navigation accuracy is, I know how fast the battery is going to deplete, and I underpin it with data to show that I understand it. That's how I actually even get permission to start doing it. Right? And then I take that same data and I plan what I want to do, and then I can account for all the possible things that might happen in the ocean environment out there that could cause that mission to not work out right. And again, I go back to data and I say, okay, have I ever performed in a 3-knot current? Oh yeah, on this day we saw that. Okay, what happened to the vehicle? How do I have to offset it? How long can it operate? How's that going to affect everything? So really, every single thing we want to do with our autonomous systems, relies on having a sound data environment to be able to execute that plan and to know that it's going to work out the way we want it to and not have something untoward happen.
Thank you so much for that. Dr. Thurgood, I'm going to go to you for the next question. You've helped scale defense innovation in both government and private industry. How is the speed of tech development, particularly autonomous systems, reshaping what's possible, do you think?
I think that's a great question. I think it has to do with the piece that Rob just talked about, right? If you think about autonomy at scale, what does that really mean? And what does it mean in the terms for the Department of Defense? What does it mean in how we think about warfighting and the characteristics of war and the nature of warfare? And I think if you think about the idea of replacing a human with machine, I think is how most people talk about it. I think there's a different answer to that question. I think the question is, how do I do the task better with the combination of machines and humans? That's different than just robotic replacement. The second thing I would think about is, instead of saying autonomy at scale, how do we scale autonomy? Right? How do I use autonomy maybe at the ground force fight, when it's an individual fight, I don't need a lot of autonomy. At a command fight, where you're fighting multiple echelons across multiple geographic spaces, I might need more autonomy. So I think it's not autonomy at scale. I think it's how do we think about scaling autonomy appropriately throughout the battle space. In order to do that, we have to think about innovation a little bit differently. Innovation traditionally is somebody has a good idea and we figure out how to apply it to a warfighting outcome. That is a way to do it. Maybe a more effective way to do that is get with our war fighters and have a really deep discussion about how do we think about warfighting and what do we think is different between the older generation of warfighters and the young digital innovators in warfighting. Oftentimes we will give a piece of equipment to a soldier or industry. Andrew, in this case, will develop a Roadrunner, and here, we developed it to do this, and a soldier will go, let's do that with it. And we're like, that is a really good idea. That's not what we think about. So the innovation idea, autonomy can help us through the rapid sequence, excuse me, and the rapid pace of innovation. It doesn't mean that autonomy gives you an innovation. It means it helps you spur ideas. It helps you break the barriers from the earlier question. And then at the critical time, as mentioned in the earlier panel, bring the right humans in to help realize that innovation in the aspect of the Department of Defense. And so when you think about innovation, it's not only the speed, but it's the resources it takes to do that, right? Industry can do that innovation at speed with resources at a much different pace than the Department of Defense can. That's not an evil thing. It's a natural state of how the department thinks about money and spending money, and how Congress thinks about money and spending money. And then how do we actually do that in industry? And it's a little bit different. And sometimes we try to force those together, and really we should celebrate the nuances of the differences and then bring those nuances together.
Thank you. Vice Admiral Goucher, you mentioned processes before. And so thinking about technology transformation isn't just about tools. It is really encompassing people, policy, and processes as well. Have you encountered any resistance with autonomy? And if so, how did you overcome it?
Yeah, so I mean, I think there's always the question of something might go wrong, right? So that is the natural cultural resistance that we have. And I mean, in fairness, we do a lot of high consequence things. And sometimes, there are things that could put a human's life at risk. And so I'm not going to compromise or take any more risk than I absolutely have to in that situation. But sometimes the methods that I use to protect a human life don't need to be applied the same way to a robotic system or to things that are lower consequence that might cause damage, something else. But we tend to let better be the enemy of good enough sometimes. And so we try to apply these very rigorous and restrictive sometimes processes to things that don't require them. And so I'll give an example. If I'm building a submarine, I'm building that submarine and it's going to go hundreds of feet beneath the surface of the ocean. And I need to engineer that, and I need to test that, and I need to design that in a way to make sure the people on board of it are safe. Well, when I send a robot down, now there's a cost to that, so I certainly don't want to lose the $1 million robot, but it is much different than the human life. And so I have to be willing to take that risk, and I have to sometimes be willing to know that, yeah, there's a chance it might, but I have to figure this out so that I can move the ball forward. And so, and I think it really happens at the lower levels. Everyone's afraid I'm going to get in trouble if things don't exactly go right. And you sometimes have to really rip that off. And so we, in the last year, deployed autonomous underwater vehicles that were launching and recovering from a submarine torpedo tube. We've been trying to do this for a long time. It's a hard challenge because the submarine's moving, the ocean current's moving. You're trying to put a 12-inch diameter vehicle into a 21-inch diameter tube, so there's not a lot of clearance. We went out and tested it in the fall, and I had kind of burned the bridge or burned the ships on the shore and said, we are going to deploy this. And sure enough, we lost the vehicle. It was bad weather. We had a ship there that was supposed to recover it, but we just couldn't get it up. And so guys came to me and like, oh no, we only have one now, so we can't deploy it because we're supposed to deploy with two, and we lost it. And I said, nope, I don't care, just deploy it with one. But it took, it had to be my level that said, we're going to send it out outside the normal configuration because we're not stopping. And then we went and said, we're going to do it again, and we did it in Norway, and sure enough, 30 tries, we only got it in one time, so something's not working. And then we kind of got this like, well, we tried it, nope, ship it back, fix it, and then go do it again. And we found the problem, we fixed it, we sent it back, we did it again, and we were successful every time. And so, but that's, kind of what it took. And it at the lower levels, the folks are all worried that something might not work right, I'm going to get in trouble, something's going to go wrong. And we sometimes just have to say it's worth the risk because we have got to get the learning done so that we can kind of move forward. And I'll use the SpaceX example, but we need to blow some rockets up on the pad once in a while to really learn how to operate. And that's what we're seeing. But because there's no humans involved in that, we can afford to take that risk.
Yeah. A great example. Thank you so much. Dr. Thorgood, you've led efforts to rapidly acquire and field emerging tech across both government and industry. Can you share how Anduril is approaching the challenge of accelerating delivery and impact in national security missions?
It's a pretty exciting time and a pretty exciting topic. We are at a pace where technology adaptation has to continue to increase. And part of that begins with an idea that we can do something different, and it's okay to do something different. Kind of the same idea. It's okay that we try a thing and it doesn't work, and it's okay that we need to iterate on it to make it work and go through that lessons that need to be learned. In the speed of that increases when we actually do that collaboratively with the Department of Defense. And we learn those lessons very, very, very quickly. We live in challenging times, and so in Anduril, we have a fundamental premise that we cannot behave like we have for the last 50 years. We must change the approach to which we're executing the adaptation of technology. The second part of that is, it doesn't have to be perfect. Look, our service members, our soldiers, sailors, airmen, Marines, Space Force, Coast Guard, they are smart, they're adaptive, they're resilient. And they would rather have something in their hands that can help them do their mission, even if it's not perfect. The opposite of good enough, right? And let them iterate on it. And the pace at which they iterate on it will increase the actual perfection of the piece of equipment. It's interesting when you talk about the autonomy. We expect autonomy systems have autonomy in them to be perfect, but we don't expect the behavior of humans to be perfect. We have to bridge that. We have to realize that when we put a system out there, as Rob was talking about, it may not work right the first time. We may have to go back and iterate on it. And the faster you can iterate on it, the faster you can turn that knowledge crank and the experience crank to bring to bear the adaptation of technology, then we can innovate quicker. Kind of the other way to think about this is in the legacy mindset of some, we generally try to buy things in the department on a 20-year life cycle. So that was pretty good when technology wasn't surpassed Moore's law. Maybe the idea that 20-year life cycles is probably not the right approach anymore. Now, certainly for capital equipment, for submarines, for ships, for tanks, for helicopters, for big capital equipment, we want that to last a long time. But for all the adaptation of autonomy and unmanned things and things that can help us in the mission set with manned platforms or manned actions, maybe we should really change the paradigm of thinking of innovation. Instead of buying something in a program of record for 20 years, maybe I don't have programs of record anymore. Maybe I just buy things on every 3 to 4 years. Maybe I turn that crank so fast on the department side that it actually drives industry instead of the other way around. And that's a pretty hard conversation to have because there's lots of impacts in training, education, doctrine, techniques, tactics, and procedures that affect how we change equipment in the department. But in Anduril, we believe we should change that paradigm. We should actually think about doing business differently and moving quickly through iterations. I mean, if you really sit down and ask yourself this question, does the piece of equipment that we have today in 2025 on a 20-year life cycle, how much value is it going to have in 2045? And the answer may be, for capital equipment, a lot of value. If it's an autonomous unmanned robot, maybe not much. And so we need to think about a paradigm shift about how we think about buying things and how long we sustain and keep things, both in the industry and in the department.
Great, thank you so much. We have about 5 minutes left, so Vice Admiral Goucher, I was going to give you the last word here. You've spoken about some bold goals for autonomy in military operation. What's the vision driving that push?
Well, I mean, I think I'm not compromising any security to say, we're in competition right now, and I think our pacing threat is China. And if you go look anywhere in the world, you can see, the president's come out and made it very clear we are not building ships fast enough. I mean, that's a fact. They are outbuilding us. The opportunity we have to compete with their numbers, and I will go up one-on-one with any Navy in the world in quality, but at some point quantity becomes its own quality. So the opportunity is in unmanned and robotic systems. And so we really have an advantage, one, in our people, and two, in our opportunity to leverage technology and put it to use. So I want to unleash all the sailors that Dr. Thurgood's talking about, and I want them to bring diabolical and dastardly ideas and employ technology to make our oceans free and open so that we can't be challenged by other countries that don't look for that, and they don't follow the rules-based order. Autonomous systems are going to give us the opportunity to compete with somebody who is outbuilding us in legacy platforms. And so that is, in my opinion, an imperative for the Navy, is to really embrace this opportunity to have robotic and autonomous systems throughout our fleet. And that's on the sea, under the sea, and above the sea, all domain warfare capability. And I think the real simple, why is that? They're less expensive to build for all the reasons we've talked about, inability to take risk because I don't have to protect human life. And I don't have to put now sailors into harm's way. And I can innovate much faster because I can take risk with these robotic systems that aren't these multi-billion-dollar platforms. So if they fail and I throw them away, it is much less financial risk as well. So for across all that spectrum, I see robotic and autonomous systems as being an imperative for the Navy and the DoD writ large.
Well, thank you so much. We're about 2 minutes left, so I just wanted to take a moment to thank you both for such a thoughtful and important conversation today on the panel, and so grateful to have you both here to talk to the Executive Forum audience. Any last closing thoughts for either of you?
Well, I'll just share one quick one. So Dr. Thurgood may not know it, but we're actually testing his Anduril vehicles out this week. We have a couple of operations going on, and what we're doing is we're actually planning it, we're running it, we're taking the data off, and then we're going to grade him. So hopefully here at the end of the next week, we're going to take Amazon Web Service helped us put everything into an IL5 environment. So we're now going to be able to write the Anduril code into our cloud, and we're going to have AI write the performance report. So Dr. Thurgood,
nice.
I hopefully can turn that over to you here in the next week or two.
Yeah, we're pretty excited about that. You and I'll have to have some beer next week. We're actually very excited about that. It's interesting when we talk about autonomy in terms of warfare, and you hear people say words like, in modern warfare, why would the first contact ever be made with a human? Let the first contact be made with a sensor, an autonomous system, and give us information and inform us. And those are all great comments. At the end of the day, though, I think to pile on with what Rob said, our nation's warfighting apparatus, the Department of Defense, is going to use the tools that are available to them to win on the battlefield. And they're going to do that in an ethical, value-based way. And the critical time of a human in that decision cycle, whether it's an autonomous decision cycle that's human on the loop, autonomous cycle where it's in the loop, at the end of the day, in this republic, this great country that we live in, we're going to continue to use the technologies in an ethical, value-based way, and keep the high ground in that fight as we adapt technology into our outcomes. And Andrew's proud to be a part of that, and we're looking forward to the test that's coming up, and hopefully the AI will write a great report. We'll see.
We'll see.
Thank you for having us today.
We're confident that you're going to have a very good score on that. I feel that there's going to be an excellent score. Well, again, thank you both. We're very grateful for the partnership, and thank you both for your time today.
Thank you.